Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today we're starting a new two-part series. Here it is, using FESTO Motion with Horner OCS. So in this two-part series, we're going to show you how to integrate a really nice motion control system from FESTO with the Horner OCS all-in-one controller. And it's a two-part series because we're going to show you a couple different ways you can do it. This week, we're going to actually do a demonstration using register-based advanced ladder. Now, even though this is considered a little bit old-fashioned, a lot of our users are still using the register-based approach to ladder logic. So we're going to give them a demonstration program that they can start from if they choose to integrate FESTO Motion with their next application. Now don't worry, those of you who have moved past register-based logic and are on to variable-based languages, because next week we're going to show you how to use user-defined function blocks with variable-based advanced ladder in order to integrate FESTO Motion. Okay, without further ado, let's break down today's topic. Okay, we're going to start with a quick introduction to the FESTO Motion platform. We're going to show you what the connection looks like between the FESTO and the Horner all-in-one controller. We're going to show you some of the available resources that you can use as you're putting together the system. And then we're going to spend the rest of our time really doing demonstrations. We're going to highlight the FESTO Automation Suite software. We're going to spend plenty of time on our demo program today. Remember, today it's a register-based ladder program that you can use if that's your preferred logic programming approach. And there'll be plenty of other demonstrations as well. And then remember, next week, we're going to be using variable-based logic and user-defined function blocks to accomplish the same sort of integration, just using a different approach. All right, let's get started with today's topic. All right, so as a quick introduction to the FESTO Motion program, I'm not going to spend a lot of time on this. There are plenty of great resources for you to learn more about FESTO. You can talk to your local FESTO distributor. Of course, you can go to their website at festo.com. There's just lots of information up there to learn about their servo products, including this great servo drive that we're going to be highlighting today, which is the CMMT-ST. A really versatile product, and I really have enjoyed working with it so far. Okay, so some highlights of the CMMT-ST product. You configure it using FESTO Automation Suite software, and that's accessible from the front via a dedicated configuration port for Ethernet. And then in terms of the runtime communications, that's accomplished through Ethernet ports on the top of the unit. You've got an in and an out for the field bus. And we'll be using Modbus TCP today for our demonstration, but the drive also supports a variety of other field bus protocols that are Ethernet based. All right, so if you take a look at all the components we're using today, here they are. Okay, so we've got a servo drive. Actually, it's a stepper motor we'll be connecting to the system today. All right, and then we have some other, mechanical parts that you'll be looking at. It's been a really nice system to work with, I'll have to say that for sure. Okay, so just a quick block diagram in terms of where the Horner OCS connects. Remember, the Horner OCS is an all-in-one controller, sometimes called a PLC plus HMI, that has built-in logic control with built-in I/O available, of course, a built-in screen, networking, all kinds of field bus functionality, and a lot more. And the interface to the servo is over Ethernet over Modbus TCP. In terms of the available resources for you for putting together the system, if you go to the FESTO website, they've got all kinds of user documentation, so no shortage there. Everything from brochures and listing of the different accessories and parts to detailed user's manuals that are hundreds of pages long with all kinds of great information. All that's available to you on the FESTO website. Also available for free download is the FESTO Automation Suite setup software, which you will need for the system. Of course, when you're configuring the Horner part of the system, you're talking about Cscape, which is our programming software, and it's available as both version 9.9 and version 10. Now, version 10 has been out for several months now, and it's really solid, and I think a lot of our customers have switched over to using Cscape 10. But today, our demo program was developed using Cscape 9.9, so I thought, let's just leave it in that format. So if you're happening to use Cscape 9.9 still, you can use the demo program as is. If you're using Cscape 10, well, no big deal. You just import it into Cscape 10. And of course, the other piece of the equation today is that demonstration program I've been talking about, and that can be downloaded from our website. And I believe we have also linked it to the download, that is, the download link. I think we've also linked that to today's YouTube video. All right, so enough slides. Let's go ahead and dive in to demonstrations. All right, let's take a quick look at the automation suite here. This is the FESTO software used for configuration of the FESTO motion control system. Here's kind of the main page. This is the equipment I'm working with here today. All right, I'm not going to spend a lot of time on this because, you know, FESTO has a lot of great information on their website. They've got some great application engineers. I got a little bit of help from one of them, but I didn't need a lot of help because their documentation is really good and the software is really good as well. So I'm just going to hit a couple of highlights here from a configuration standpoint. Down here under Field Bus, let's go to the configuration page. It's important, of course, that we're set for Ethernet IP/Modbus TCP. Obviously, Modbus TCP is what we're using here. All right, there are other options as well, you know, EtherCAT, etc. All right, and then the details of the Ethernet IP configuration. This is the Ethernet parameters for the drive Field Bus Ethernet port. So along the top of the drive, there are two ports, an in and an out for connecting your field bus, in this case Modbus TCP, which is where the OCS is connected. And it also has an Ethernet port on the front of the drive. That's where this software is connected to my computer on a different IP address here. So I've established a connection for configuration purposes with the front port while the OCS is communicating on the top port. And you have access to all the parameters and all kinds of setup information and everything else here. Again, I'm not going to spend any additional time on this software, but this is the FESTO Automation Suite. All right, I just opened up the demo program here, and we're going to take a look at that next. Now, I didn't create this program from scratch. I started with a program developed by one of the FESTO application engineers. You know, I refined it a bit. But basically, this is not a program I created from scratch. So thanks to the FESTO team for getting this project started. Okay, I want to give credit where credit is due. Okay, so this demo program is written in register-based advanced ladder. We still have plenty of register-based advanced ladder customers. So I thought it would be good, since this program existed, to refine it a bit and release it to customers still using this programming approach. Next week, we're going to be covering the variable-based languages using user-defined function blocks. But for those of you who just want to get started with a register-based program, you've got this right here. Okay, so let's take a look at how things are organized. From a logic standpoint, we have two main routines we've created with plenty of documentation. All right, we have a routine here that basically just establishes a Modbus OK indicator, which of course is important because all the communications with the drive is over Modbus TCP. So that's what happens here in the communication section. All right. And then we have a FESTO motion section, which I'll go through in some detail here in a few minutes. All right, but let's start with the configuration of Modbus TCP. And to do that, we're going to go to hardware configuration. Now, you've probably already noticed I'm using Cscape 9.9 for this demonstration. Again, you could use this program with Cscape 10, no problem. It just so happens the program was written for 9.9 originally, so I said, you know what? For those folks who might still be using 9.9, let's leave it in this form and release it as is. And again, that means people using either 9.9 or 10 can use this program. All right, so let's go to hardware configuration. Okay, this program is written for an XL4. I'm sure we'll have some other models that we'll release demo programs for, probably 7-inch as well. And of course, next week with the user-defined function blocks, that's completely model independent. All right, and then let's go to the Ethernet configuration here. We have to, of course, since we're using an Ethernet protocol, at the very least, we have to have our IP address and our net mask configured. So this is the IP address of the OCS controller. Okay, that's going to be talking to the FESTO drive. All right. And then down here under downloadable protocols, this is where we select Modbus client. Okay, and then we have 3 levels of configuration we need to perform. So under the network level, most things are at their defaults, but a couple things I'll point out. The timeout is lowered to about a second. So I would recommend a second or less, maybe 500 milliseconds would also be fine. Reacquire time, I've also lowered down to a second. Again, that's an appropriate value. Could even be, half a second, 500 milliseconds. And we've also assigned in the demo program we're taking advantage of the status register, which is critical, so we know we're communicating with the drive. And then we've also got a disable bit established here, okay, in case that ever needs to be used in the future. All right, but most things other than those timeouts and these status variables are at their default. So that's the network level. On the device level, okay, let's take a look at the device configuration here. This is where we just have a convenient name for the device we're talking to. This is the IP address of the drive. Okay, everything else is at its default, except, of course, we've assigned a disable device bit here, which hopefully we'll never need to use. And also status information, 2 consecutive words have been established here. Okay, so that's on the device level of things. And then on the scan list, that's nice and simple as well. We just have one group of data that we're reading from the drive and one group of data that is read-write with the drive, okay? So if you take a look at the mapping, the data coming from the drive originates at Modbus input register 30,001 through 12, and we're storing it locally as R301 through 312. And then the write data to the drive is being written to holding register 40,001 through 12, and locally that originates at R401 through 412. So again, pretty straightforward configuration here. Now, another thing I want to point out is all the references for those 12 words in and out of drive data have IO names established. So if we go to the program IO names area here, we can see that we've got all these references for drive parameters already established, okay? Okay, so everything from 301 through 412, including all the individual bits that we've mapped, or that we've named, are all drive parameters. Okay, so those are all nicely pre-named for you. Even the ones that, frankly weren't used in the demo program, you've at least got them pre-named here. The other thing I want to point out is, this is a register-based program, and we've kept all the references between R910, or let's say R900 to be round. So from R900 to R999 are where all the register numbers that we've used in this program are located. So if you've got a register-based program you want to integrate this with, just avoid that range of registers, and it'll be pretty easy for you to integrate this with your program. So you shouldn't have to renumber, rename, all those sorts of things. All right, now let's take a look at this demo program. It's really pretty straightforward. Again, I didn't create it from scratch. I just refined it a bit. Okay, so we start off with basically when the drive is enabled, okay, we set some key control bits to where we want these. Things like stop, the control by PLC bit, the intermediate stop bit. These are the quick stop bit. These are ones that need to be set. Most of them are ones that need to be set so you can do motion. And then you have ones like your limit switch, your software limit switch enable. Those are turned, this one's set to off. So any key control bits that you need to turn on, you just put a coil here. And the ones you want to turn off, you put a normally closed coil. Okay, so anyway, we set some control bits. We enable operation whenever the enable push button or toggle button is pressed, and we've got several screens we've defined. We'll show you those shortly. Whenever the enable drive toggle switch is toggled on, we set these control bits, we turn on the enable operation bit, and then 1 second later, we turn on the enable access bit. So we give it a little bit of time, and then we enable everything with one button there. And then the rest of this is, pretty straightforward stuff. So we have a clear error function where whenever the clear error push button is pressed, we set the appropriate bit. We've got jog up and jog down. Okay, again, push buttons that set the appropriate control bits. We have the home function. Whenever we push the home button, then we set the appropriate bit. And then down here, we've got a little bit of math on some of these parameters, things like velocity, velocity override, acceleration, deceleration, etc. So in the case of velocity override, okay, the way we are presenting these on the screen for the user is to do it in terms of percentage from 0 to 100%. But the way the parameter is reported to the drive or sent to the drive through a control word is, first of all, it's sent as an integer in this case, and 100% corresponds to 16,384. So we're taking our 0 to 100% that the user enters, multiplying that by 16,384, and then that value is expressed as an integer is what we send to the drive. And that's the same equation we use for the velocity override, the acceleration, and the deceleration. They all use that same approach. And then down here, we've got a couple more parameters with a slightly different calculation for velocity and target position. Okay, so these are handled as part of the factor group value in the drive. So for more details on what a factor group is, check out the drive documentation. But effectively what we do here is we take the value that the user enters on the screen from 0 to 100%, and we multiply that by 1,000, and then that is sent as a double integer to the drive through a control word. And then target position is similar. Okay, we multiply what the user enters by 1,000 by 1,000, and then that's converted to a double integer and sent off to the drive. And then I think what you'll find on the drive end through this factor group is that the drive, I believe, is going to take these values and divide them by 1,000. So that's why we're doing that. And then down here, we've got an execute move function, which is really, again, just press the appropriate push button on the screen, and then you're going to turn on the appropriate control bit to execute your move, assuming, of course, everything is ready to go. And then one other thing here of note here at the bottom, and that is the drive has what's called a record mode or direct mode that you can use. In direct mode, you effectively enter in the position that you're going to, and then it executes that position. That's the direct mode. In record mode, it basically grabs stored positions from its own internal memory. I think it has up to 127 internal records that you can pull from. And so then you can just, pull your destinations from those internal memory locations or records, if you will. So if you're going to use record mode, then this control bit would need to be off. If you're going to use direct mode like I am in this demonstration, then I have to make sure that the toggle switch we've got for direct mode is on, because if that switch is off, we're going to be in record mode. Okay, so that's what the logic looks like. Again, pretty straightforward stuff, plenty of documentation. And going back to this FESTO COM section here, you can see there's plenty of documentation here for your configuration and more. All right, so finally, let's take a look at some of these screens. Not going to spend a lot of time on these because we're going to show you a demonstration on the bench. But we have effectively on the right here and along the bottom, we have some jump keys to jump to different screens. These screens here are really all designed to look at drive parameters. Okay, so just to toggle and find drive parameters and look at their current value, that could be useful. And then this screen is where we're going to do things like enter in a target position, our override velocity, velocity acceleration and deceleration. We've got a clear push button here. We've got a drive enable here. We've got an execute task push button here. And then we have some important status LEDs up here. So if our communication is okay, which is key, right? Because we're communicating with the drive over Modbus TCP, then this LED will be lit up. If we have an error, we'll get this LED to light up. And if the position is okay, this LED will light up as well. Okay, and then another key screen that we have, well, let's take a look at a couple of them. The next screen is our jog home and fault detail screen. So that's where our jog up and jog down buttons are located. We've got our home push button because we have to be home or have a home reference established before we can really move. This is that direct mode toggle that needs to be on for you to enter in the destination positions directly from the keypad. Okay, so that would need to be on. And then a duplication of the execute task button, so just another location for one of those here. A couple of convenient locations to look at actual position and actual velocity. All right, some details on warning codes or fault codes you might get, plus another duplication of the clear push button and the access error LED. So this is a convenient page for jogging and finding home or establishing home. And then we have a Modbus TCP status stage, which will hopefully be showing this as solid on, and then we should have good responses counting up rapidly, and both of the slave statuses should be 0. And then the rest of the screens are really just looking at key drive parameter bits. So if you want to know the status of any particular bit at any particular time, you can navigate to each of these screens that have each of the control words and status words of note that are detailed here, okay? All right, so that's what we have established for the demonstration screens. And again, this particular demo program has been written using Cscape 9.9 Service Pack 11, but of course you can use Cscape 10 for it. It's also been written using register-based advanced ladder. Next week we'll have all kinds of tools for variable-based advanced ladder as well. And another thing you could do, you could take this program and you could convert it using Cscape 10, you could convert it to a variable-based advanced ladder program. Actually, you could convert it in Cscape 9.9 to a variable-based advanced ladder program if you choose, okay? It would keep all the mapping that exists as is, and then you could then add your program using a variable-based approach. So lots of options for you. Again, this week we thought the key was to give you a program you could start with, and we said, hey, we've got a register-based program established. Thank you for the guys at FESTO. Let's go ahead, clean it up a bit, and release it. Okay, we're powering up the system. You can see the drive LEDs here. Nice large indicators, which is nice. And the OCS is booting up, of course. Okay, so what we're waiting on is a solid comm light, which we have. Okay. We also do have an error indication here, so that needs to be cleared before we can proceed. So let's press the clear button here. Okay. You can see we've successfully cleared that error. Now we can enable the drive, and we should go solid here. And you can hear some servoing going on in the background. All right, very good. But before we can move, we need to make sure we have a reference established or a home established. So let's go to the home menu here. And let's say this is a good enough position for home, so let's just establish this as home. All right, our actual position now goes to 0. You can see that here. All right, that's a toggle switch, so I'll untoggle it there. Let's go back to home. And then now we can do some moves. We've got override, velocity, acceleration, deceleration values here. I've got a position target of 25. Let's just go ahead and go there. Okay, and now we can move position wherever we want to go, and everything is moving the way we want. Okay, so this gives us a nice head start. This demo program gives us a nice head start so we can quickly get our application established. All the drive parameters are in there. You've got variables already created. The communications is already set up. You've got, the basic rungs that you need, all that sort of thing. And if you want to go through any of the parameters, you can do that right from the screen. So, you can quickly see the status of all the status words and control words of note, because those are pre-configured in the application. Okay. All right, so hopefully this demo program will give you the head start you need to become really efficient with your application. Okay, so that does it for our topic for this week. This is where I remind you we're here just about every Tuesday at 2 o'clock. Whether we're fully live, pre-recorded, it doesn't matter because we always have someone standing by to answer any questions you might have if you're watching live. Just give us those from the chat section. If you're watching a replay, we're still looking for your comments and questions. Just give those to us in the comment section. Okay, the training schedule is posted. Check out our website at the link provided and get signed up now. Now, you're also going to have plenty of opportunities to see us during 2025 because we've established our trade show schedule. So the first one is a trade show in Indianapolis, which is our home city. It's a water and wastewater equipment-based show. But then, of course, the big show, the next big national show, is Automate in Detroit in May. And then, of course, we've got a great regional show, which is the Manufacturing Expo in Grand Rapids. That's scheduled for August. And then WEFTech, which is the water industry show that's also national in scope. That's going to be in late September and early October. So we'd love to see you at one of these trade shows this year. Okay, lots of ways to interact with Horner. You can do so on our website at hornerautomation.com, our YouTube channel where we have hundreds of videos like these, and of course we're also active on LinkedIn. And as a reminder, next week we've got part 2 of our series where we're going to be showing you another way of interfacing with FESTO Motion, this time using variable-based languages and user-defined function blocks. Okay, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications with a little bell, then you'll be notified every time we go live or every time we post a new video. Okay, so until next week, where we talk FESTO Motion in part 2, that is, where the camera can see my fingers there. Let's all get out there and do us some good.